Hello dear students, I welcome you all for the lecture of processor architecture and interfacing. In this lecture we are going to see how 8051 microcontroller interfaces DAC. In the previous lecture we have seen how 8051 microcontroller interfaces ADC and sensors. ADC is analog to digital converter. DAC is digital to analog converter, which is exactly opposite to that ADC. As we know that microcontrollers are used in wide variety of applications like for measuring and controlling of physical quantities like temperature, pressure, speed, distance, etc. In these systems, microcontroller generates output which is in the form of digital numbers or digital pulses, but controlling systems requires analog signals as they don't accept digital data. Digital to analog converter is used to convert digital pulses to the analog signals. If you want to judge the capacity of DAC, please consider the resolution, which is a function of number of binary inputs, and that resolution will uh, confirm the capacity of that DAC. We are going to use DAC 0808 for our application. 8-bit DAC provides 256 discrete voltage or current level of output. In DAC 0808, the digital inputs are converted to the current, that is I out, and by connecting a register to that I out pin, we convert the result to the voltage, as digital systems accept those analog signals which are converted from digital number to the analog signals in the form of voltages. The total current provided by this I out pin is a function of binary numbers at D0 to D7 inputs of DAC and the reference current RF as follows. If you observe this formula, then I out will be calculated by this formula where D0 is the least significant bit and D7 is the most significant bit input for the DAC, and I reference is the input current that must be applied to the pin. The I reference current is generally set to 2.0 milliampere. If you observe the interfacing diagram of DAC with 8051 microcontroller, at D0 to D7 input lines of DAC, we are getting the digital numbers, digital pulses from the microcontroller. These D0 to D7 lines of DAC are interfaced with port 1 of 8051 microcontroller. The other things are same as we have seen in the while interfacing 8051 microcontroller with ADC. Let us focus how we will get the output. Here output will be generated. This is our I out pin. Here output will be generated. The V reference positive is connected to the plus 5 volt power supply and V reference negative is connected to the ground. Observe this figure. The generation of current reference V reference is shown by setting plus 5 volt power supply and 1 kilo ohm standard resistor. This is 1 kilo ohm standard resistor which is available here. Now, assuming all the inputs to the ADC as a high, the maximum output current will be generated as 1.99 milliampere. If you assume all the inputs available at the DAC are high, for example, D0 is 1, D1 is 1, D2 is 1 and so on, D7 is 1, and let us consider that I reference is equal to 2 milliampere. Then if we calculate, we will get the generated current or output current as 1.99 milliampere. Okay, and this current whatever we got here at this output pin, that will be converted into the voltage because digital systems accept those analog signals in the form of voltage. So ideally we connect that output pin to the register and convert this current to the voltage and monitor the output at the scope, but it causes inaccuracy since the input resistance of the load where it is connected will also affect the output voltage. So, I reference current output is isolated by connecting it to the operational amplifiers such as 741 with R is equal to plus 5 kilo ohm for the feedback resistor. So I hope you have understood how to interface 8051 microcontroller with DAC. In the next lecture we will see how to interface 8051 microcontroller with keyboard and stepper motor.